Hello and welcome everyone. My name is Arpad Georgic, and this is the third Azure online meeting we organize. I hope you are all doing well, staying healthy, and I do hope that these events we organize can help you to stay focused. This time we will talk about databases, Azure, and the combination of these two elements. As always, I would like to tell you that if you have any feedback or if you have any comments, we would be happy to hear your voice. So please drop us an email or post a comment in meetup.com because we would like to be better in this, what we are doing with this meetup organization. So I hope you will enjoy the presentations of today. And first, I would like to hand over to Károly from T-Systems, who will talk about database encryption techniques on Azure. Károly.
Okay, so let's start with the introduction about myself and about our company, because probably already aware of that we have changed our name from IT Solutions Hungary to Deutsche Telekom IT Solutions, first of all. So this is just a general announcement for you. And then my name is Károly Oravec, and as far as you can see, I'm a cloud solution architect, and I'm working for Deutsche Telekom IT Solutions, right? And I'm responsible for architecting, designing, and optimizing on either securing the cloud infrastructure in our enterprise for our enterprise customers. Okay, and today we are gonna talk about transparent database encryption. Okay, so what that means? That means I will give you a short introduction about the technology, how it works. Then especially we will focus on, of course, on Azure and on all those building blocks and all those technologies surround the transparent database encryption, how these things fit together, how these elements make this feature to be up and running. And then I will give you a demo related to this. If everything goes fine, and even if not, but at the end, we will try to discuss the lessons learned, what we learned so far, and yeah, of course, all the issues or the possible bottlenecks will be discussed, okay? And maybe we will have at the end a short Q&A for questions if you have any, okay? So let's get started. Okay, so what is transparent database encryption and how it comes into picture? So as I mentioned, I'm working for quite large enterprise customers, and one of them had a request for to build up a highly secured environment where literally everything should be secured and everything has to be top level secured, right? So if we are talking about security, there are different layers, there are different levels of security, right? And in our case, TDA means that I want to encrypt my database because the customer was afraid of that if his database is compromised or it's technically stolen, which is probably less possible in public cloud, but still it might happen on any way. They want to make sure that the database is not accessible to those hackers or any other person who get that database, right? So if I go to the second point, what that means with one sentence, database and transparent database encryption is encryption at the rest. That means I'm encrypting both the database and the log files as well. And actually the encryption is done at the page level. That means when the data is read from the disk and put it to the memory, loaded into memory, then it's decrypted by the engine, and then it's available for read, right, for DBAs, for everybody else to be used for a certain task. And when it's it's written back to the disk, then it's encrypted again. This is in a nutshell how it works. But if you can see this picture, you will figure out that there are certain differences between the old traditional way of encryption, how it worked, and with the new way which actually was implemented by Microsoft. So if you are looking for traditional way, there are actually the database itself is encrypted by a database encryption key. That's fine. But we are using another certificate which is used to protect that key, the database encryption key. And that certificate, unfortunately, or by design, it's put it into the master database. And if we are looking from a best practices point of view, this is really not the best practice when you are holding a key together with the data, right? And this, the solution, the extensible key management, or using Azure Key Vault as an Azure service should be a solution for our pain. That means that I'm using a key, put it into Azure Key Vault to encrypt and decrypt the data inside of SQL Server. And in this way, those two main components are differentiated from each other. But otherwise, just bear in mind that all those technologies here highlighted are pretty similar if I'm installing, if I want to use, for instance, this Azure Key Vault integration with my on-premise or physical environment. Exactly the same procedure will happen and exactly the same setup will be done, except that I have to install manually the SQL Server connector, but the rest of the things, the Azure Key Vault and everything else should be done. And all those components are also in use, so everything should be the same. So this is why I highlighted the solutions, what I mentioned here in point 4, that we will talk today about IIS solution, a typical IIS solution that I have a SQL Server installed inside of Azure VM, but actually all other Microsoft database components could use the same terminology and the same technology because so Azure SQL managed instances or even for reporting data warehouses could be encrypted in this way. Also, just to highlight Azure Key Vault, what is Azure Key Vault? Azure Key Vault is used for storing secrets, certificates, and keys in one place. And then those keys and certificates can be used by applications, by users for further process, right? Yeah, in nutshell, this is a very this is the how it works and what are the main components. But bear in mind that there are two steps of encryption and decryption, and there are two certificates used, because in later I will explain it in more details how it works, and actually I will show it to you in a demo. So in Azure, and this is the main element of our presentation, because this is what I wanted to highlight. This is what I, from my experience, not always people who are working with databases are not always 100% familiar with Azure terminology or with public cloud concepts. This is why I'm trying to explain these things to get the knowledge about it and to be more handy with these features. So what I need in order to get this setup up and running. First of all, I will need an Azure AD application. So why do I need an Azure AD application? Because the AD application has a service principal inside of it. And this service principal, imagine that this is a service user, right? So this is a security entity which has a password allocated. It has his own password as well. It's called a secret, right? And this secret has to be stored on a safe place when you are generating it. So only once you have access to it directly from the portal. After that, you have to create a new secret, or you have to somehow restore your secret from your backups or from your KeePass file, okay? Because you can't really use it. I mean, you can really reuse it, but you can't access it anymore, only at the point of creation, right? You have to create a key vault, that's for sure, okay, because this is a key element of us. You have to upload a certificate. Why I'm saying PFX file? Because both private and publicly are needed for our exercise. And yes, you have to double check if the resource provider is enabled. So in Azure, everything literally is built up from resources. And if there are two ways to enable the resource provider related to Azure SQLIS extension. Either if I'm installing a virtual machine from Azure Marketplace, which has a pre-built and pre-configured SQL server, then the resource provider will be automatically enabled. Then you have no any further activities with that. But if you are installing a separate VM, and then again you are installing manually an SQL server, then you have to take care of a resource provider. You have to go under subscription and enable the resource provider. It's quite important because otherwise the whole solution won't work. And then we get to that stage when I'm jumping into the demo, because now we will technically enable the Key Vault integration. If everything works fine, then yeah. So give me a sec. I will go to my resource, and there are plenty of resources. As you can see, here's my virtual machine, and this is my SQL virtual machine, which is nothing related to my real virtual machine. Actually, here are all the settings. This is the setting. This is the collection of my SQL server settings related to my original VM. Okay, and here are all the main components which can be configured if I have this extension up and running. Sorry, one more thing. If I go back, here is my virtual machine. And for virtual machine settings, this is what you have to double check. This is the SQL Server Agent extension. First of all, status provisioning succeed, very important. And if you have a version 2, this is the full manageability. This means the full manageability. This is why I'm seeing all the settings related to my SQL server. Otherwise, those settings will be grayed out. Okay. Now, which is the most important part for us, I would like to enable the Key Vault integration. This is the very first step in order to get the TDA work, right? So I will go here, and what I need for this, I need first of all, give me a sec. Maybe I can do this in this way. I will go to my. Here's my another section where I have my those components up and running, the Key Vault. So the Key Vault has a public name. This can be accessed, but only problematically. So if you put it into your browser, probably nothing will happen, but still it's here. So I have to use the URL principal name. Yeah, so the principal name immediately, principal name is not a name. I have to use my ID, which is, give me a sec. I need to use my application ID, which is in Azure AD, right? So if I go to my Azure AD and I pick up that application that I already created, okay, so here is my application for SQL encryption, and this is the ID. This is the principal name, okay? This ID, what I need. I will copy it here. Principal secret. Okay, so if you look at for the secrets and certificates, this is what I was saying too. When I created the secret, it was available, the value, the password, right? But I can't hear it anymore, and I can't copy it right now. So I can't use it. But of course, I have it. I copied it already to my notepad, and I will use it again. So give me a sec. We are here. Okay, credential name. This can be literally anything, so it's not stick to any particular conversation. I will use this credential name, and I will try to apply this. So hopefully this will enabled, this will be done. And in the meantime, sorry, I will stay here, but I will go to my virtual machine. What I'm expecting to happen. So here is my SQL server. It's already up and running, right? It only doesn't have this security feature enabled. What I'm expecting SQL Server connector to be installed. And when the connector installs, this is just a DLL. And this DLL will register a cryptographic provider here, under here. And then, of course, that credentials, what I added previously, it will be put it here, the credential. The credential is very, very important. This is the technically this credential is the connection between my Key Vault and between my SQL Server environment. And then after, if everything goes fine, then I will run all these commands here and make sure that the TDA up and running. So, okay. It looks like it has been enabled and it has, okay, fine, good. So now we have this up and running. I will go back here. I will say refresh. So you see, this is the credential what I use. Okay, what I put it into the setup. And here is the technically this is just a security a cryptographic provider, which if you look at the credential, it's connecting to the Key Vault, my test Key Vault, and yeah, using these credentials. Okay, so now we have a logical connection between my Azure environment, between my SQL Server and the Key Vault. But now I need to do more stuff, right? So first of all, because the changes, the first part of my changes has to be done in name of my local admin, which is technically also the sysadmin in our case. And probably this is not the same for most of the environments, but of course, because of demo, I use the same account. In your case, if you have a separate admin who has a sysadmin rights, then you should, of course, first of all, put it here, the login, and from logins you have to, pick up that account which you are currently logged in, and you have to add this credential to him. Okay. So now, if you look at my DB admin, it has this credential assigned. Okay. So we are now able to do the certain tasks. Yeah. So just a quick explanation on this. This is the key, the asymmetric key what I uploaded into Key Vault. Okay. The name for it could be anything, right? Now I'm creating the asymmetric key. Technically, this is the asymmetric key which will be assigned in further tasks, okay, in order to use the database encryption, right? But I have to create it, okay. Okay, so we are good. So we used the certificate uploaded into Key Vault. That's clear, probably. And then, again, another tricky session. What is this? So I have to create a login. This is just a programmatical login. Okay, it can't be really used for real life environment to log in anywhere else. But this login, which was just created here, this will get two things. It will get the asymmetric key created before, and it will reassign that credential what I created previously. But in order to get assigned, I have to drop it. So I have to get it from my admin account. Okay. Sorry, I use my previous server for this, of course. So now I have to assign this credential to this programmatical login. Okay, good. We are halfway, so we are not too bad situation. And now I will create quickly a database. Okay, this will be my database for testing the the whole solution. Okay, the only thing what I have to care of is the name, right? And just to double check if, okay, where is my, here is my database. And if you look at the, it's still not encrypted, right? So any encryption enabled false. Okay, and now we are almost there. Now you see what I explained in the, sorry, what I explained in the very first slide, that there is a second step. So I have to create a database encryption key. Okay, so this is what we'll use by engine to encrypt the database. Yeah, okay. Master is not good for this kind of exercises. Okay, so we have now the encryption key, the asymmetric key for database encryption key enabled, up and running. Still the very last stage to enable this stuff. Okay, should work, right? So let me double check this. Options. Okay, ta-da. So the whole solution looks pretty simple and straightforward. Still, I think there are some confusing parts, but hopefully now we, I don't know, explained and clarified all the steps that what we have here. Okay, so that's all. That's all for the setup, and for the actually for demo part. So I will jump back to my presentation in order to explain what has happened. So, and what you should be aware of. Okay, and what I learned actually from my previous experience. So the EKM provider, this is the SQL connector. The SQL connector, when it's installed, when you are enabling the Key Vault, it's automatically installed, right? Except if you are in on-premises environment, then you have to install it manually. And maybe this is the better solution, because when you install it automatically through the Key Vault setup, it will give you the 1.0.4 DLL version, right? And this is the wrong one. So for production environment, it won't work. It will hang out, and we will have plenty of issues. You have to upgrade it manually, but the setup can be easily downloaded from the internet, and it's a quite simple stuff. Azure AD permissions. So again, when I'm accessing the Key Vault with my credentials from SQL Server, I'm accessing actually through the service principal, okay? And if I don't have proper rights for Key Vault for that particular Azure AD application, in brackets for the service principal, these ones, what you can see here, the whole setup, again, it won't work. Extension has to be in a full mode. That means that 2.0 has to be the final version of it. And yeah, that's it for this. How I was showing too, the extension, it's easily understandable that what you need in that stage, but actually it can be gathered from PowerShell as well. So that's fully clear. And one more really interesting thing what I faced when I set up the whole infrastructure and everything else. So during the SQL agent installation, I don't know, something went wrong, or maybe it was done by a couple of persons who don't have enough rights. And I would highlight to take an attention on this account, because this, what I was missing during our setup in production environment, this login, you see, this was missing from here. And if it's not here, actually it has sysadmin rights. And the SQL agent, if you want to try to enable the Key Vault integration, it will give you a big error message because it doesn't have enough rights to do this. Okay, so this has to be here. Okay, everything is, this is like technically the SQL Server agent. Okay, So be careful about that. This is what you really need in our case. Okay. So of course, the whole setup can be done automatically from templates as well. So you can use RM templates. You can automatically build up the infrastructure and put all those necessary requirements. Yeah, one more thing. What is my database? So I'm using Enterprise, Developer, Enterprise, and I think Evaluation Edition can be used only. It won't work with standard version, right? So the standard, if you are using standard version, again, it will give you an error message. You won't be able to enable the Key Vault integration, okay? So that's all from my side. I wouldn't hand over right now. I think we have a couple of minutes for the Q&A session. Okay, give me a sec. I will go with this here. And then let's see if there are any questions. Just please let me know. We can answer those ones, of course, later in either by email or via email or anyway. And the whole session will be recorded, of course. So I think that will be available for us. But please let us know if you have anything here any concerns about this or yeah. I'm always not sure if silence is good or not for us, but yeah. Hopefully you get some good hints here. Okay, Eleni, I would say stage is yours. Good luck. Thank you.
Thank you very much, Károly. Okay, let me share my screen. Okay, I hope this is okay. So hello, everybody. My name is Eleni Santorinaiou. I am a technical specialist at Microsoft working as a global black belt. So this team basically is responsible of supporting customers on advanced workloads on Azure. I'm working with open source databases, NoSQL, Kafka, Stream, and so on. And today we're going to speak about NoSQL. Now, you will not hear from me that NoSQL is the only way to develop cloud-native applications. For sure, NoSQL answers some requirements for cloud-native applications, but so do relational databases, caching, Kafka streams, as I said earlier, and so on. But today we're going to be talking about NoSQL and the concepts behind NoSQL distributed databases. You will mostly see NoSQL databases being the backend of distributed applications. And you need distributed applications if you want to achieve basically availability and latency. So you want to answer questions like what happens to your application if a region becomes unavailable? And regarding latency, how do you improve customer experience? How do you improve response times when users are on another continent? So the topics that we will cover today are three, and we are going to see the trade-offs between those three topics. These are consistency, latency, and availability. And I want you to leave this meetup basically with understanding when you design a distributed system, how do you need to think about these three topics. So let's start with consistency. Consistency in the distributed system is not the consistency that we find in the ACID model of this. Consistency is basically when we read an entity from a node in a distributed database to get the same data, no matter which node we are querying on, right? So the distributed databases follow the theorem, the CAP theorem, which was developed in one of the universities, I think in MIT, a couple of years ago. which basically says that you cannot have all three of those. You need to decide and make a trade-off between two over the other. So a trade-off between consistency, that means that you always need to get the most recent write, otherwise you will get an error. The availability, that is that every request that should receive a response, otherwise the applications will not be available. And the partition tolerance, which is that the application and the system continues to work even if a replica loses connectivity. So to make this more in a diagram, let's say, so in the event that we have a partition in the network, we have to make a decision between the availability and the consistency. And basically this means that if we choose availability and we write in the master and we are expecting the write to get replicated in the secondary node, this will be fine, right? But when we have the partition in the network and we receive a new write on the master database, this write, this new document, will not be able to be replicated if the replica is down, but the user that is reading from the replica will still get a response back. Now, if we choose consistency over availability, this means that the moment that we have a partition in the network, any new write in the master will not be committed until the replica gets back live. Okay, so CAP theorem is fine because it describes what happens in the event of a partitioning on the network. But the question is what happens when we do not have a partition in the network. And here it comes the Puzzle's theorem. Allow me to read it. In the case of network partitioning in a distributed computer system, one has to choose between availability and consistency. So this is the CAP. But else, even when the system is running normally in the absence of partitions, one has to choose between latency and consistency. And this is why. This is because when we have a distributed system, then the nodes might end up being in different data centers, right? So there is always a latency for the data to be replicated across regions. So if we have a partition in the network, we have to make a trade-off between the availability and the consistency. And this is where a lot of distributed databases that we know as developers, like Mongo, for example, make select, let's say, one over the other, right? So Mongo is known to be more availability oriented, while Cassandra, for example, sorry, the opposite. Mongo is more closer to consistency, while Cassandra is closer to availability. If we do not have a partition in the network, we have to make the decision between the latency and the consistency. So let's see what happens if we choose consistency. In that case, until the data is replicated on the replica and until the replica responds back with an acknowledgement that I got the new document, the application is not available. So I cannot read any data until the data is replicated. Because consistency for me is very important, so I always need to get the latest write. This happens for every new write that happens on the master. If I choose latency, this means that I'm always on, right? So eventually the data will be replicated on the secondary node. And until then, I will read the data that has been already committed and replicated across the network. This might be fine if, for example, consider some applications like social media platform or a blog or a news feed, right? So you do not need to get always the latest data across. So think about this kind of applications and not just transactions and that need to be made in the application. Let's start with the demos. So basically, in the first demo that we will see, we will try to understand what is the impact of data locality and how close the data is to my users, the effect that latency has, that this data locality has on the latency. So let's see. So in the first demo, it will be showing basically an application that is sitting on East US, and my database is sitting on West US. So two different data centers with 2,000 miles distance between each other. We are going to perform 100 reads from this database, from the client to the database. Okay, so let's see what is the latency like. So we see that there is an average of 70 milliseconds read latency for the request that we are doing. Now, if you are a bit familiar with CosmosDB, the SLAs that CosmosDB provides is basically that all the reads that are performed with certain requirements, let's say, there is a guarantee that the reads are getting done in less than 10 milliseconds. So you can imagine that this 70 milliseconds is already too much. Now, we decide, after we see this performance, that we need to basically bring the data closer to the users. And how we are going to do this is really easy and nice, I'd say. So let me show you on the portal. So on the portal, we have the map with all the data centers of Azure. We see now that our database is deployed on East US, while our application is running in West US. So basically what we need to do is just click on the map and copy the data wherever our users are, right? So you see how just clicking on the map it is. I will not save this because I already have another account for this, but basically, just to show you, the multi-region is here. So in this account, my master database is running on East US, and the secondary database is running on West US too, right? Where my application is. So all the reads that are happening closer to West US will be performed will be served by this database. So let's see how this will change the latency. In the blink of an eye, you see that the average latency for a request that is happening within the same data center, of course, drops dramatically to 2 milliseconds. This is impressive, and this basically shows exactly this, that the data locality does make a big difference in the performance and in the latency. From 70 milliseconds, we dropped it down to 2 milliseconds just by copying the data to another region close to the customers. Okay. Let me... So, moving on. This is fine because we explain what is happening with the reads, but we do have the writes as well, right? So with the write latency, what is it happens? Still, I'm reading from okay, I'm reading from the region that is close to my customers, to my users. But when I have to write, I need to write across the country, basically, then get replicated and be able to read from there. So that's why CosmosDB, in order to fight this latency and bring the write latency even to a very low level, has introduced a feature of multi-master. And this means that every replica in my account is fully writable. And this manages to bring the write latency in less than 10 milliseconds as well. So what we will show in this example is the write latency. So now we performed reads. We will do the benchmark for writes when our users are writing from East-US, and we will see what it happens when I write to East-US or when I'm writing to West-US. Okay. Let's see. Okay. So first of all, with the multi-master, we just want to confirm that reads are not going to change. So performing 100 reads from West US to West US, I get 3 milliseconds latency for as an average. Let's see what happens with the 100 writes. If I have a single master and I'm writing from East US, I'm writing in East US from West US. So basically, we get the latency that we had before, and this makes sense because I have to cross the network, let's say. Let's see if I do the multi-master, enable the multi-master, and this is something that you can enable when you create the account of CosmosDB. So now I'm just performing the reads, and the reads should have no difference as we expected. And now let's see the writes. Now, repeating, multi-master writes should be in less than 15 milliseconds. Indeed, we get 13 milliseconds. There was some outliers here, this 1000 milliseconds, but as an average, we get less than 13 milliseconds. You will see here, and you might notice that the cost for these writes is 23 request units. And the request units, for those of you that are new in CosmosDB, is a normalized currency for the performance and the cost of CosmosDB. So let's say that the compute, memory, and disk required to do a read of 1 kilobyte document is 1 request unit. To write a 1 kilobyte document, it will cost, as we saw earlier, 8 request units, right? So here it takes 23 request units, and you might wonder why. And I'm going to answer to you just by showing the multi-master account that we have set it up here. As you see here, we have deployed CosmosDB in 3 regions. So it's like multiplying the cost of one write to the 3 other regions that are available, the 2 more regions that are Cosmos, the data needs to be replicated. So that's why we get 23 request units per write. So this is something that you need to keep in mind. Just by clicking on the map and becoming available everywhere means also that you need to your writes will cost more because it will need to be replicated across different data centers. Okay. All right. Let's see now the consistency models. We understood how latency is impacted by the data locality. And now we're going to see the consistency models that CosmosDB provides. Basically, it provides 5 different models, and this the default one is the session. So I can say that like 90% of the accounts that are getting deployed on Cosmos do not change from the default setting, and they stay at session. Now, the more write you go, the consistency becomes more relaxed and the latency becomes much lower and the throughput becomes even higher. And we're going to explain why weaker consistency means higher throughput. The lefter we go on the spectrum of the consistency, the consistency becomes stronger. We have higher latency because basically we need to wait for the data to be replicated across regions, and the throughput becomes lower, and we will explain why this happens. In the session, basically, it means that you read your own writes, right? So you are imagining chatting, right? And you are able to see what you have sent to the other person. Or you are adding items to your basket and you are able to see your basket. This is your session consistency. The eventual consistency means that the data will be eventually replicated across the nodes. And there is no guarantee for the order of reading them. In the consistent prefix, basically you get this guarantee. It's a bit more relaxed than session. So, and you also get a guarantee of the order that the reads happen, that the writes arrive. On the strong consistency, we have the exact opposite of the eventual. So you get the latest of your reads are always consistent with the writes made. And the bounded staleness is basically that you put some limits on them how much stale your data can be. It can be an amount of time, or it can be a number of updates behind, let's say. Now you see that there is a direct relationship between the latency and the consistency. And it makes sense, as we said, because in distributed systems where you want to put your data close to your users, you need to travel across the one network. And this has a limit, like the speed of light has a limit, but also it becomes even slower because of the different components in the one network, like accelerators, routers, and so on. And the other thing is that when you decide to go for strong consistency in multiple regions, this means that you sacrifice the latency. It's something that you cannot choose you cannot select to do for regions that are further than 5,000 miles. So you cannot have strong consistency between the data center in India and the data center in US or Singapore and North Europe, let's say, because the latency would be really, really bad. The other thing about the throughput that we mentioned is basically that, okay, let's start from, even when you have one region and you do not need to replicate to multiple regions because your data is, your users are in Hungary, for example, you get 4 replicas. So within one data center, you get 4 replicas. And this is how also CosmosDB guarantees the 4-9 availability. Basically, we have one leader and 3 followers. And when the data arrives at the leader, it gets copied out the followers. If I replicate in another region, one of the followers becomes the forwarder and copies and sends the data to the other region. Now, if I'm having strong or bounded staleness model, consistency model, then I have to read from two followers, from 2 replicas in order to provide this consistency. This means that I'm touching 2 nodes and this read costs 2 request units. For the session consistent prefix and eventual consistency models, the same read would cost 1 request unit. For the writes, So what this means that if you have, let's say, the minimum 400 request units and strong consistency, it means that you can read basically 200 requests per second, because every read costs 2 request units. For the writes, the difference that we get on the cost, there is no difference at the cost for the writes. The only difference that we get is the latency. So all the writes cost 8 request units, and unless we have strong consistency, where we need to get the majority in the other regions as well in order to respond back. But this impacts only the latency, not the cost of the operation. Now, let's see the demo for this. Cool. Now, in this demo, what we are doing, we have 2 data centers deployed in 2 data centers, one in West US and one in Central US. And we're going to test eventual consistency between those 2, what is happening with the latency, and eventual consistency latency, strong consistency latency. After that, we are going to put the replicas even further. So we will keep the West US as is, and then we will copy the data in East US. And we're going to test strong consistency with the 2 data centers, with the 2 regions. So again, testing 100 writes between the 2 regions that are in West US and Central US. You see that because we have eventual consistency, excuse me, we have a latency of 6 milliseconds because it's enough basically to write in my region, and eventually it will get replicated across Central US. Let's see now if I change the consistency to strong. So basically now I need to wait for the data to be replicated to Central US before before the write get committed. As expected, this is higher. The latency here is higher, and now I want you to make a guess, to make a bet basically on how this latency, how much this latency will increase now that we separate the regions even further and we have East US and West US. That yeah, so now we have the 2 replicas 1,000 miles apart, and basically we will increase this to 2,000 miles. And as some of you might have guessed, the bigger the distance, the higher the latency. So here we have almost double the latency with 104 milliseconds average write latency. Although you see that the cost of the request units remains the same, right? 8 request units if you have eventual consistency, 8 request units if you have strong consistency. The only change is in the latency. And now what I want to show is the throughput for the reads. We have eventual consistency, so we just read from a single replica. And as expected, this costs only 1 request unit. Now, if I change the consistency to strong, I need to read from at least 2 replicas. And that's why the cost of this operation is 2 request units. We saw here that the throughput in the writes remains the same, 8 request units. The read throughput increases when you have eventually consistency, and the latency also increases the further you add the replicas and when you have strong consistency, because you need to wait for the right to be committed. Let's go to the third topic, the availability. So basically, the way to increase availability of your application, of your system, and so on, is to remove single points of failure. So for that reason, you keep adding replicas of the application and every database as well. So when the user is reaching, doing a request to the server, basically the traffic manager that acts here as a load balancer sees where the user is closer to, what is the closer region to the user, and directs the request to the right data center. Now, if I have a single master account database, this means that if in the event that the region becomes unavailable, there is the option of manual or automatic failover, and one of the replicas will become the master and will get the rights. Okay. Basically, as a developer and as a user, you pick the priority of the regions that will become master and the primary region. If you decide to do it automatic, this gives you a 15 minutes window that the application realizes that one of the regions is down and then promotes one of the replicas to master. If you decide to do it manually, this might be even shorter because you might see it from monitoring a bit earlier and then promote it yourself. So when you design an application, you have to understand what is the RPO and RTO that the application can manage. And the RPO is how long you lose data, basically, and the RTO is what is the time that the system becomes available again after a disaster event. Now, in this table, you see basically the different RPOs and RTOs that you get based on the consistency model that you choose and based on the number of regions that you have deployed and on the multi-master selection. You might notice that even with strong consistency and multi-master setup, you cannot get both RPO and RTO 0. And this is because of the Passel's theorem and the CAP theorem and the trade-off between the availability and the consistency. Okay, yes. Now, one question that you might have with this multi-master feature is basically how we manage the conflicts and how we resolve conflicts. What happens if a user is trying to update or insert the same document in different data centers? And basically, Cosmos provides a very, I'd say, flexible management of conflicts. There are three options. One is the last writer wins, which is it's the default, it's the most used across customers. The second is the custom merge stored procedure that is available only for the core API, the SQL API. And the last one is that you decide to do nothing automatically. The conflicts are becoming available on a conflict feed that you can read and then decide which document will win, let's say. So with the last writer wins, as we said, it's something that you can change on the profile. And basically, you can choose any numeric value or just the timestamp of your document and decide which feature, which property is to be the critical one. In this example, we have chosen the user-defined ID. So the user with a higher defined ID wins. Let's say here, Satya Nadella wins Scott Guthrie. The custom merge stored procedure is a JavaScript stored procedure, basically, that is available, as we said, only for the SQL API. And basically, you can choose how to manage the conflict. And the last one is that you you manually resolve, basically. So you put in the store procedure a blank page, blank field, and then you read the feed of the data, of the conflict feed. Now, let's see how this looks. Okay, all right. So the first example will be with the last writer win. So here I will try to create conflicts, to insert conflicts on the regions, the different regions, and I've set as a winning policy that the max user-defined ID wins. Okay, we see here that from the documents that have been inserted, the document with the user-defined ID 603, which is the max one, should be committed. Now, if we go back to our account, is here. First of all, yes, let's see here. We have chosen the conflict resolution to be last right wins here, and the conflict resolver property to be user-defined ID. So it's simply as this. Going to the items that have been inserted, yes, we see that indeed the user-defined ID with 603 won and got inserted in the database. Now, if we go to the user-defined rows, yes, you will see here that the conflict resolution mode is set to merge procedure. There is a merge procedure already here. And with this merge procedure, we basically choose the document with the lowest, with the minimum user-defined ID to win the conflict. So going back to my application, we are going to use the minimum user-defined ID to decide the winner of the conflict. So here we expect that Yasmin Coucher with a user-defined ID 49 to be winning this conflict. And if we go to the items, and reload. Okay. It's not Brielle, it's Yasmin Coucher. Indeed, the document with the user-defined ID 49 got committed in this conflict. And the last one is also quite interesting. It's not used so much, but at least it gives you an idea that you can, if conflict is something that you are not expecting generally, then you might want to manage it, to resolve it like this. So in this one, Okay, we have generated the conflicts, but so you see that the first insert is the one with the user-defined ID 283, and then somebody tried to update the documents with these 3 different IDs. So basically, what we will see in this here. Is the first one, and in the conflicts we will see the conflicts that so the current document is this one, and we see that there is an update at this document that comes from a different region and with a different user-defined ID. And basically, we decide to run an application to read the feed and decide how to process it. So here we read the feed. We see that there is one conflict to process. The conflict is the 561, and the already committed is the 429. So if the updated one has a lower number than the current one, then it wins. In this way, the committed item is the winner. Yes. So if I agree to that, then coming back to the application, to my data. Yes, so I see that the data, that the conflict was made with a user-defined ID that was bigger than the current one, so it didn't get committed. And my previous one won, let's say. So closing up, just want to tell you that there is a free tier of CosmosDB, which basically provides 400 request units every month. So you can do some dev test environment there. Everything you need to know is available on gotcosmos.com, where basically it has trainings, code samples, labs, new features that have been introduced, and so on. The the benchmarks that I show you are available on GitHub, and really they don't consume a lot of throughput, so you might want to try them yourself. And the main key point to take here is the differences and the trade-offs that you need to make basically when designing a distributed application between the consistency, the availability, and the latency. And with that, I would like to see if there are any questions on the chat. I will stop. There is one question. That was for Károly. Let me know if you have questions, if you have tried Cosmos already. What was your experience? Did you like it? Did you hate it? How you feel like, you know that there is a rumor for CosmosDB that is very, very expensive. I want to know what is your view on that, or how convenient was for you to start with it. I don't know also if you can unmute yourself and speak up. Otherwise, yeah, use the chat or the Q&A window to write your thoughts. In any case, you can, as Károly said, you can reach us on LinkedIn or on in the emails. There are no questions. Then thank you very, very much for joining on a hot July afternoon for these sessions. There will be no other session during the summer, so we will be back on September, hopefully. Thank you all again, and see you soon.
Thank you. Bye-bye.